Hello, this is Stephen Withrow with Webucator. In this video, I'm going to show you a solution Tomas Nurkiewicz came up with for dependency injection syntax sugar over function composition. Tomas agreed to let us create this video showing his solution, which is available as an article here on his blog at the URL shown here. Tomas indicates that dependency injection is syntax sugar that hides function currying and composition. To set this up, he has a scenario. In his scenario, bank statements will be parsed and then stored. We see a parser object and a storage object in his sample code. Tomas indicates that object-oriented programming is actually a misnomer. He shows us some code from the anti-compiler Java P, and in this code, a call such as this.database insert is actually going to be converted into database, that is a capital D, against the class .insert. So we can forget about objects. Now in the revised code, Tomas has a final variable of type parser and a final variable of type storage that is used to process the payments. Next, Tomas will rewrite the function into the Scala programming language. Here, the parser and storage and the statement file pass to the import file. Notice the getLines function will be invoked against the source, and then the output of that will be processed by the map function, and then each item will be saved into storage. Objects can be used as dependencies, but in this example, storage and parser are not really necessary. The function can be applied to do the equivalent processing, and that is indicated in the revised example here, again written in Scala. I have taken Tomas's scenario and I have converted it into a Java application, and I have converted the banking application into a vendors application. Here we have a list of vendors, and we are going to filter the list and then print the list. This will require the application of functions as arguments to a method. The method is getFilteredList. When I call the method, I'm going to pass lambdas to the method, which will provide the implementation of the functional logic. The result will be we will print a list of vendors that are filtered with a particular criteria. This criteria can be set every time the function is called. Now I'm going to execute the code. First, I will list all of the vendors, and then I'm going to apply the ideas that Tomas talked about so that we can filter the vendors list with criteria that we can set using the lambda every time we call the function. In this case, I'm calling it one time applying filtration, specifically looking for vendors that have a capital A in the vendor name. We could call the function arbitrarily many times and change the criteria for the filtration. Also change the criteria for what we're going to do every time we process a particular vendor. Thanks again to Tomas for the inspiration for this video. Check out his blog at the URL shown here for other articles on Java and Spring programming techniques.